Welcome back to The Explainer, everyone. Today, we're putting on our academic hats and taking a highly structured, rigorous look at how we measure the true environmental footprints of the things we make, use, and throw away. We're talking about a process known as life cycle analysis, or LCA. If you've ever wondered what the actual quantifiable cost of a product is to our planet, and I mean way beyond just the price tag or the obvious factory emissions, you are absolutely in the right place. Let's get into it. So let's establish our foundation right out of the gate. What exactly is a life cycle analysis? Well, according to the academic framework, LCA is a systematic process to assess environmental impacts associated with all stages of a product's life. And by the way, this applies to an entire process or an activity too. It works by meticulously identifying and quantifying the energy used, the materials consumed, and the wastes generated. Then it assesses their impact on the environment to ultimately pinpoint and evaluate opportunities for real, actionable environmental improvements. Here is our roadmap for today's explainer. We're going to break down this standardized framework phase by phase, starting with the cradle-to-grave concept, moving into defining goal and scope, then life cycle inventory analysis, life cycle impact assessment, and finally, interpreting the final results. Starting with phase 1, the cradle-to-grave concept. We love a good biological metaphor in environmental science, don't we? When we say cradle to grave, we are literally mapping out the entire existence of a product. Step 1 is the cradle, pulling and processing raw materials straight out of the earth. Step 2 covers the manufacturing, the fabrication, and crucially, the heavy transportation required to move all those materials across the globe. Step 3 is the consumer phase. That's you and me actually buying the product, using it, maintaining it, maybe repairing it. And finally, step 4 is the grave, the recycling and ultimate disposal after its useful life is over. The big takeaway here? Environmental impact happens at every single one of these stages, not just on the factory floor. Moving right along to phase 2, defining goal and scope. Now, before we collect a single piece of data, we have to understand that an LCA is never just guesswork. This is a highly structured, internationally standardized procedure. We're talking strictly regulated by the International Organization for Standardization, specifically the ISO 14040 to 14044 series and the ISO 14047 to 14049 series. Sticking to these rigorous standards means an environmental assessment done in Tokyo is methodologically totally valid and compatible with one done in Toronto. It levels the playing field. At the very outset of setting our scope, we have to ask ourselves two massive, fundamental questions. Why are we conducting an LCA for this product, process, or activity? And who is actually going to participate and do the work? We need an explicit written statement explaining exactly how and to whom the final results will be communicated. Because, trust me, without that clarity up front, a study can lose its academic focus and real-world applicability really fast. This is where we draw our lines in the sand. Detailing these specific elements creates a clear technical boundary for our work. Your goal and scope document has to outline the chosen impact categories, the strict system boundaries, and exactly what product or service is actually on the table. We also have to establish a functional basis for comparison and the required level of detail so any comparisons we make later actually hold up mathematically. Oh, and like any good researcher, we need to call out the expected challenges in the study right from day one. No surprises. All right, phase 3, life cycle inventory analysis. To truly grasp this phase, you have to look at what it produces. The result of this exhaustive inventory analysis is the LCI model. Notice the exact phrasing we're using. It provides information about all inputs and outputs to and from the environment from all the unit processes involved in the study. Basically, think of this LCI model as a massive, incredibly detailed accounting ledger for the Earth. Everything nature gives to a process and everything that process dumps back out gets logged. It all starts by charting out the technical system so we have a crystal clear picture of our boundaries. And populating that massive environmental ledger, well, that requires meticulous data collection across these specific heads for every single stage of production. We are talking about strictly quantifying energy inputs, precisely measuring raw material inputs, and accurately tracking every emission released back into the environment. All of this highly structured data is then gathered to build comprehensive computer flow models, which end up being the backbone of our final reporting. Next up is phase 4, life cycle impact assessment. So how on earth do we take a mountain of raw numerical inventory data and translate it into a concrete understanding of environmental damage? The ISO standard brilliantly handles this by dividing the impact assessment into mandatory and optional elements. The absolute, non-negotiable requirements are selecting our impact categories, doing the classification stage, and assessing the impacts on the environment and human health. Then you have the optional, advanced elements, normalization, grouping, and weighting. Let's peek at the core mandatory side first. The absolute heart of the mandatory process is the classification stage. This is where those hundreds or thousands of raw inventory parameters are sorted and neatly assigned to a limited number of specific impact categories. Because, let's be honest, trying to interpret a chaotic spreadsheet full of random chemical formulas and energy joules is a nightmare. This mandatory classification organizes that vast LCI model into manageable, understandable metrics that directly relate back to the environment and our health. Now, what about those optional LCIA techniques? They are actually incredibly powerful tools. Step 1 is normalization. This is where we take our impact category results and compare them directly against total impacts in a specific region, which gives us vital scale and context. Step 2 is grouping, which is simply sorting and ranking those categories. And step 3 is weighting. This is where different environmental impacts are weighted relative to each other so they can literally be mathematically summed up into a single number representing total environmental impact. It is a fantastic trick for distilling highly complex data into something highly accessible. And finally, phase 5, interpreting the final results. As any veteran analyst will tell you, interpretation doesn't just mean throwing numbers on a slide. It starts with intense, aggressive scrutiny of accuracy. We absolutely must ensure that our summarized inventory and impact data actually meet the initial goals and scope we set way back at the beginning of the study. Once validated, those results are summarized and presented as concrete conclusions and recommendations. Because ultimately, why are we doing all this rigorous academic work? The whole practical purpose is evaluating clear, proven opportunities to reduce energy, minimize material inputs, or mitigate environmental impacts at each specific stage of the product's life cycle. This entire methodology takes environmentalism from a broad, abstract philosophy and turns it into an exact, actionable science. And that brings us to the end of our explainer today. But before we wrap up, I want to turn this academic framework directly back onto you. Considering its entire cradle-to-grave journey from the extraction of raw materials in a distant mine, through global manufacturing to your home, and eventually to its final disposal in a landfill, what is the true hidden environmental cost of the very next item you purchase? The formulas and frameworks are absolutely there to calculate it if we dare to look at the numbers. Thank you so much for joining me today. Stay curious and keep analyzing the fascinating world around you.